Hey guys, welcome to our first ever data structures tutorial. Today we'll be learning about introduction to data structures. So let's get started. First thing, we'll start with introduction to data structures. That is a definition and basic understanding of what data structures is. Then we'll look at the different types of data types. Okay, that is primitive and non-primitive data types. What are they? What is the difference between them? And then finally, we'll look at the different types of data structures. Alright, so let's get started with introduction to data structures. So what is data structures? The definition goes like this. Data structure is a way to store and organize data so that it can be used efficiently. Data structures should be designed in such a way that it reduces the complexity and increases the efficiency of the database. Data structure addresses three issues. First one is called data search, that it helps in the increase in the speed of data search. Then processor speed, and finally it helps in handling multiple requests at the same time, that is simultaneously handling multiple requests. Before understanding what are data types, you need to understand the basic concepts of data. There are multiple ways of representing data in computers. The basic unit of data is a bit, and information in computers is not always interpreted numerically. Every programming language has its own set of data types, and that brings us to the most obvious questions. What are data types? Well, data types can be defined as an abstract concept that defines an internal representation of data in a memory. Data types can be divided into two categories: primitive data types and non-primitive data types. Primitive data types form the basic unit of data structures. Primitive data structures can hold only a single value, and the commonly used primitive data types are integer, character, floating point number, and double precision number. What about non-primitive data types? Well, non-primitive data types are the structures that can store data of more than one type. These data types are user-defined data types, and non-primitive data types are called reference types also. Examples of non-primitive data types are arrays, linked list, string, stack, tree, etc. Alright. Now what about abstract data types? Well, abstract data types mainly involves two parts. First is how components are related to each other, and operations that can be performed on the data type. Alright. Now we have learnt about different types of data types. Now we'll learn about different types of data structures. Data structures can be classified into two categories. First one is called linear and the second one is called non-linear. Now linear data structures are data items that are arranged in a linear sequence. For example, array, linked list. What about non-linear? Now non-linear data structures are data items that are not present in sequence. For example, a tree and a graph. Okay. Now we'll learn about each of these different types of data structures in detail now. Alright, so let's at least start with the basic introduction of all these data structures, what they mean and what is the definition. What is an array? So an array is defined as the set of finite number of homogeneous elements. Very simple definition. And how do we declare an array? So we declare an array like this. First we write int, that stands for the data type that we are using, integer. Then we write square brackets, and inside the square brackets we write the size of the array, that is the number of elements we want to store inside that array. Array helps in reducing the use of number of variables, as we don't need to create separate variables for every element. Now let's look at the next type of data structure, linked list. Linked list can be defined as a collection of variable number of data items. Linked list is a linear data structure where each element is a separate object. Every element contains at least two fields, one for storing the data and the other for storing the address of the next element. Now let's look at the next type of data structure, that is stack. Stack is an ordered collection of elements with a special feature that insertion and deletion can only be done at the top of the stack. It is also called as last in, first out, LIFO type of data structure. It has two principal operations, push and pop. We'll learn about each of these data structures in detail in the next videos. Alright. Now what about the queue? Queue is a first in first out type of data structure. Stack was last in first out, and queue is first in first out type of data structure. The two main operations in queue are enqueue and dequeue. Enqueue means insertion inside the queue, and dequeue means deletion from the queue. New elements are added to a queue from the back of it, that is the rear end, and the elements that are removed, that is deletion, happens at the front end. Now we are done with the linear type of data structures. Now let's look at some non-linear data structures. So first non-linear data structure that we are going to look at is known as tree. Tree is a non-linear data structure in which the data items are stored and arranged in sorted sequence. Trees represent hierarchical relationship between various elements. So as you can see over here, we have got A, and there are two children of A, B and C, and then again B has 2 children, D and E, and C has 2 children, F and G. So this is how a tree looks in terms of representation. Now let's look at the final nonlinear data structure, that is a graph. Now when we saw a tree, it was non-cyclical, that is no cycles were formed inside the tree. Okay, so there is only one way to reach from point A to point C or point D. There are no more than one ways to reach that point. Okay, but in terms of graph, that is not the case. A graph is a pictorial representation where some pair of objects are connected by links. A graph is a set of vertices and set of edges. An edge connects a pair of vertices and may have weight. So as you can see over here, we have got A, B, C, D, E. These are the 5 vertices, and we have got some edges over here. AB, AC, CD, BD, DE. Okay, these are the different edges. There are multiple ways to reach from point A to D. We can either go from A to C and then C to D, or we can go from A to B and then B to D. There are multiple ways to reach from A to E. You can go from A to B, B to D, D to E, or A to C, C to D, D to E. So it is a cyclical representation, or you can say when you convert a tree into a graph, what you do is basically you form a cycle and then a tree can become a graph. So this is the basic introduction to data structures. We have learnt about linear and non-linear data structures. We have learnt about what are different types of data types. If you have any queries, feel free to ask me in the comment section below. Thank you.
So that's it for today, guys. Thank you very much for watching. If you have any queries, feel free to ask them in the comment section below. If you have any suggestions, please write them in the comment section below. If you like the video, please share it with your friends and subscribe to my channel. Thank you very much.